Hello, I'm coming back. Kapoy ko. Kapoy ko discuss, guys. Okay, welcome back to my...
The Bluetooth device is ready to pair.
Hello guys, welcome back to my YT channel. Once again, I'm Singer Channel Voice. Welcome back to my discussion all about forces. Oh my gosh. I almost covered all the different types of forces, right? It's gonna be like that. So we will be focusing, concentrating more on the problem solving after. Okay, but for this, we need to introduce theories and concepts of the forces. I already discussed to you, right, the gravitational forces? Or not yet? Okay, we'll recall that one, huh? To make sure. I'm just discussing the electromagnetic force, right? Kalas. Okay. Like that. This is kalas, right? Okay. So to give a brief description, this involves electric force or magnetic force, something like that, through moving particles or electrically charged particles due to the force of attraction, something like that, right? And with its corresponding velocity covered with a magnetic flux, like that, in a magnetic field and electric field, is going to be electromagnetic force. Okay, so the key point here is the Lorentz law, right? Lorentz. Mr. Lorentz discovered this electromagnetic force is going to be like that. Okay, that this is the force. I mean now that Lorentz law, specifically. Okay, I already give you the brief description of electromagnetic force, but I still have also to state this Lorentz law all about. Basically the same, but you know, the way it's being phrased in the definition. This is a force exerted to a particle with a moving velocity through electric field and magnetic field. As simple as that. That is Lorentz law. Okay? So, to give a brief formula for that, it's going to be electromagnetic force is equal to the charge of the electric force plus the charge of the magnetic force with its corresponding magnetic field, ng ganun, di ba? Times the magnetic field. Okay, flux density or magnetic flux, it's totally the same. Okay? Number two, we have the, like that, I discussed it already, so we need the gravitational force. Okay? Not yet discussed, right? Okay. So actually guys, electromagnetic force, electric force is already also discussed, right? Okay. And magnetic force. Okay. I will state this clearly that you know the magnetic force and the magnetic field will depend only through the moving particles, the electrically charged particles. But if we will consider the charged particles by its static position, meaning not moving, okay, it is not covered by magnetic force. That's only the difference between the electric force and the magnetic force. Because electric force covering both, whether the charged particles are moving or static. But this magnetic force specifically, okay, referring only to the charged particles that is moving, not static. You get the point? So that's why magnetic force always involves magnetic flux. Because, okay, the velocity of these electrically charged particles will, rotate in a circular path. Okay, but the electric force, you mean, we don't necessarily mean that all the time is moving, both static and moving. Okay? So that's very clear. You have to point the difference, only one difference. For magnetic force, meaning to say, it's not static, always moving. Okay? But electric forces can be static and can be moving. Okay, that's why electric force is more comprehensive rather than magnetic force. The magnetic force is purely more on the law of magnetism, law of polarity, or law of polarization. Ganon. Di ba katong like poles repel and like poles react. Always like that. But there's no static. electric force cover there, okay? There's no such term as static magnetic field or static magnetic force, okay? That's very clear, right? Okay, we go to the gravitational force, mga palangga. So gravitational force, what do you mean by this? It's always directed downward to the Earth's surface, no other. Or it's in the solar system, gravitational system present there. The heavenly bodies, the planets, okay, the 9 planets revolves around the center to the sun, right? These are examples of gravitational force. We have also the gravitational force in the inside the Earth, and we have also gravitational force in the universe. Okay? So the universal gravity force in the universe is more compared to the within the gravitational force exerted by human beings in the planet Earth. That's the point. Because if that is the case, we are floating in the outer space, but we are really on the ground, meaning to say we have gravity, but not as strong as the gravity of the planets rotate or revolve around the orbit towards the center, the sun, something like that. You get the point? You get the point, mga kalangga? Yun yun. It's a gravitational force. That's why our formula for gravitational force, whether you are inside in the planet Earth, or whether you are in the outer space, or the solar system through space and time, you get the point? It's gonna be like F G is equals to the Newton's law of gravitation. See, it carries the Newton's name because this is his discovery. Okay, Newton's law constant or gravitational force constant times the mass 1, mass 2 over distance squared. Ganon. So take note mga palangga, this is this word, right? Okay, meaning to say if the gravitational force is very strong, meaning to say it is expected that the distance from the sun to the planet is very also far. Okay, because if it is very near, so problem, there will be no such more gravity. So again, the planets will just, not following the orbit. Okay, that's why always like this. Okay, strong gravity, meaning the distance is very far from the sun. Okay, because the center is the sun in the solar system. That's the reference. But in the planet Earth also, we can apply this also. This mass and mass can be any objects also. Okay, not necessarily mean the planets. But in the solar system, this M1 and M2 could be the planets. Considered it could be Venus, Earth, Neptune, the mass of the Neptune, the mass of the Venus, something like that. In the larger scale in the universe. But inside the planet Earth, we can only refer to any object as long as it follows the same principle, the centripetal forces, meaning the forces directed towards the center of the nucleus, or the reference to be considered in the centroid. Okay, the forces meaning is towards, directed towards, not away. Okay, that's the point. It's gonna be like this. What is our constant for gravitational force? It's gonna be 6.67 times 10 to the negative 11, then Newton meter squared, kilogram squared. So you should also memorize this, because this is the constant of the gravitational force. If the question in the future will ask you, compute the mass of Jupiter. Compute the mass of Jupiter with the distance from the sun to Jupiter is, for example, 21,000 miles. So you can compute now the mass of Jupiter. Okay, so you can compute by having this formula. Okay, or it could be, modified like this. What is the gravitational force exerted by Pluto with a distance of 300,000 miles away from the sun? Like that. And it's also this formula. If you know the mass of the Pluto, blah blah. Actually, there's a table also. If this kind of problems will appear in the questions. Table, meaning there's a given. Mass 1, mass 2, blah blah blah, so and so, like that. So that you can easily compute. But normally, it will trick you out by just giving only one given and then it will be asked in a question. Because the constants are always expected to be memorized. You get the point? The constants are always expected to be memorized in science subjects. Okay, not necessarily in math, because in math you have to derive. Okay, not necessarily memorizing the formulas. Anyway, you can create your own formulas out of your derivation if you can connect different formulas in one, in one simplified situation, in one simplified correlation, in one simplified linkage. You have to link, and then you can have your own derived equation. Okay, but in science, you have to memorize the constants really, guys. Maabtan mo siyam-siyam if you're trying to derive only one constant. Okay? Mahurot imong oras. Mag-compute lang ka. For example, if you try to compute what is the constant of Planck's constant in the theory of, the photons, energy released by the fluorescent bulb, like that, or the incandescent bulb. You will calculate the particle of the photon because the particle emitted by the bulb is called photon. And then you ask to compute what is the distance or the velocity of the photon, okay, emitted by fluorescent bulb. Just like me now, I'm standing in front of the fluorescent. There is photon and particle released towards me. That's why I see the light with corresponding, wavelength of the particle and also the frequency. Okay, if that is the case, I can see the white light is coming, something like that. So this is a visible radiation. Because colors will appear due to visible type of radiation. One type of radiation that exhibits and produce color that can be seen by our eyes. This is also one type of radiation. Okay? Apart from the radiation emitted by the radiant heat of the sun, the ultraviolet, okay, radiation, or the ultraviolet rays of the sun. This is also one type. Okay? Another type also is the radiation through sound waves. We can hear the sound if somebody playing the music. That is also radiation through sound. Okay, and another also through light, such as the lightning. Okay, like that. That's also part of radiation. And you have also the infrared radiation. You have also the gamma X-ray radiation in the hospitals. So, the coverage of radiation is very wide and comprehensive. That if you're trying to study a science course, especially a master course, you have to master this topics because it's really covered by scientific research. If you want to proceed nuclear chemistry, like that, whatever. if you want the title to become a nuclear engineer, like that, or nuclear physicist, okay, nuclear chemist, nuclear chemical engineer, something like that, then you will be able to master these types of radiation or nuclear transmutation. Okay, the topic of the general chemistry lecture. Okay, something like that. So, it's gonna be on naabot taglayo because it's part of gravitational force, right? Okay. Now, number 3, so we have the strong nuclear force, Schwada. Okay, and the weak nuclear force. Okay, but actually we can, make this as a nuclear force only. Splitting to two, it's just okay, but actually for me, I will just put this in one. But the book stating this separately, because their main purpose, because the strong nuclear force are so many coverage under this, and also weak nuclear force are so many also coverage under this. That's why they separate this. But actually, this is under nuclear force, right? If I try to dig it out. Listen, two types of nuclear force, the weak nuclear force and the strong nuclear force. Diba? So it's gonna be like that, but in the different books and references that I really researched and studied 20 years ago and now, so it's gonna be like, they separate that, okay? But we will not argue for that, just leave it that way, that these are the 4 types of fundamental forces. Sa ako na itong explanation. Okay? Ganun siya. Now, how can we explain? Gravitational force, okay na siya. Dali na siya. Okay, and then, dali lisod ni siya is, wait. Lisod, both are difficult because we are studying particles and subatomic particles. This, number 3 and number 4. Okay? I think this is more difficult compared to the number 3. Okay? But we will start a little bit with the weak lang muna, ha? Okay, weak nuclear force. Okay? Nakakaloka. Si weak. Magsugod ka sa weak. Okay? Weak nuclear force. Kung saan yung mga weak nuclear forces, uy, nakakaloka. Wait, yung mga sa coffee, guys. So, take my braces. Sure. Nakakaloka. Diba? Nakakaloka. Guys, with nuclear forces, let's also understand a little bit of electromagnetic waves. Because partly related. The number one type of force is partly related to the weak nuclear force. Why is it partly related? Because it involves electromagnetic waves, such like that. Okay, and then it covers on the electromagnetic spectrum, something like that. For example, the light. The light has particle behavior and has also a wave behavior. So it will follow the duality, the particle wave duality theory. Something like that. To the point mga palangga, muna nahitabo sa light exists as a particle because the particle is photon being released by the light, and a wave also because it travels at a certain wavelength, something like that, and with corresponding frequency before it will produce a light that can be seen by our eyes in our day-to-day life, such like the paper, like that, or else we cannot see if there's no radiation or visible light produced by this fluorescent, whatever light, neon lights, incandescent bulb, whatever, practically related also to electricity. The things like this, guys, is really interconnected, right? Interconnected with each other, the electricity, the electromagnetism, and the radiation, really. Okay, something like if you try to dig it out, dig, meaning you go to the, sa kinagaluman siya, galing siya sabtun. So you can understand really the, ganon, diba? Ganon siya. Pwede maglibog. Okay? Para kagawa sa examination, ako ikag-score sa theory. Okay? Mga theory. Naogo na mo sa theory, wala na. Pasar na yun ka. Kasi gamay natin yung problem solving. Kaloka. Diba? Ganon. Eh, daghan ba yung theory, guys? Okay? Kaloka. Pang theory na ay. Okay? Ito point sa ang weak nuclear force. Okay, muna siya may tabo kang kayo na. Ang weak nuclear force, guys, can be attributed to radiation. Hala. Wow, I love radiation, Sir Sotero. Yes, without radiation, all of us we will die. Why? Because we cannot receive the heat of the sun. Planet Earth has no light if there's no radiation coming from the sun, which is the ultraviolet rays produced by the sun through radiant heat energy. Okay, so without this kind of radiation, then nobody exists in the planet Earth. Okay, because in the first place, there will be no photosynthesis, chemical reaction in which the food we will eat every day through the process of the photosynthesis and absorbing the light energy of the sun, it will undergo phosphorylation process in which the phosphorus element coming from the sun will fortify and combine to the glucoses in the plants. It will give us energy to survive. Okay, take note, phosphorus. Without phosphorus, there will be no food because this is the activation energy to make the photosynthesis be completed to produce the carbohydrates we gain from the plants. Get the point? So phosphorus is really free from the sun. That's why we need phosphorus because this is also useful for the development of our bone as well as the calcium. Okay, calcium. Get the point? Through the absorption of calcium through vitamin D. Okay, and phosphorus as well. They are, combining each other for our bone health. To avoid osteoporosis, the weakening of the bone, and to avoid osteomalacia, the softening of the bone. You get the point? Before going to osteoporosis, your bone must be softened first before it will be detached. And after that, you will develop osteoporosis. And then, katigwang mo bako na kayo ka because your lack of calcium, vitamin D, and element phosphorus inside your body. Ganon. Okay? So that's related also to radiation. Pakaloka. Okay? So if I will try to discuss everything, no, the whole night will not finish. Really, if you try to discuss, and then tukiwa na po na ako, ano say kuan, it will never end. Magtan kung 24 hours to discuss this whole thing. From electromagnetic force, gravitational force, hindi lang ako matulog, sige lang ako discuss. That's why other vloggers make a script. Script, meaning they do the vlog by script. Meaning they prepare, they organize, they systematize, they memorize, they prepare. But in my case, I will never prepare. Okay, what comes on my mouth, automatic, that's it. And what I'm going released from my mouth, that's it. What you heard, what you say is what you get, something like that. Yun the point mga palangga umikan, ganon. That's why it took me a longer time compared to other vloggers because my vlogs, my contents are not scripted. Okay, not prepared. Okay. Kanta ko man eh. Diba? Peanuts are the food for the brain, right? Is that true? I don't know. Okay? With nuclear force, makalihaw rin ako niya force that I love it. Wow. Why? So why you love it? Because there's a lot of emissions, something like that. Okay? So, radiation, by the way, guys, who discovered radiation? This is the most basic thing that we need to understand first before going further. Who discovered radiation? Okay? Now, what is the difference between radiation and radioactivity? So the difference, actually it looks like the same, but there is a clear distinction among the two. Very small distinction between radiation and radioactivity. Okay? How can you explain that on the spot? Nakakaloka. Hi. Okay? Radiation is a process and radioactivity also is a process, right? How can I differentiate this? Okay? Okay, it's gonna be like this. Radioactivity, guys, will only refers to really the element, the atomic element. Okay, but the radiation covers the whole thing, whether it is an element, a solid, a liquid, a gas. For example, if I have a radiation by using the Stefan-Boltzmann constant, okay, that radiation means related to gas, okay, gaseous emitted by the sun, which is the radiant heat of the sun, right, and ultraviolet rays of the sun. So that is not necessarily an element. That's only a type of, a gas into the atmosphere that will be released to you. Okay, another thing also. But another thing for the radiation. Okay? Radiation, for example, a laser like that. Okay, laser. Light through light. Okay? Not necessarily an element. Right? But the radioactivity, focusing on the element. How this element can do the process of radiation. Example, if Sotero will experiment the radioactive material, example, I will try to pick a sample of iridium into the laboratory, and I will try to discover, what is this radiation strength of this, iridium? This is under radioactivity, not necessarily radiation. Okay? But basically just the same, but only a little bit slight differences. The radioactive thing makes it the same. Okay, but the reference, the medium you use is not really totally the same. So that's the difference between radioactivity and radiation. That's why we say, who discovered radiation? So many scientists will appear to discover radiation. You cannot exactly specify who are they. Right? But if you speak who discovered radioactivity, it's specific. And who is that? This is Henry Becquerel. Discovered first the radioactivity through the element known uranium. Okay, on this experiment. Okay, and after that, followed by Marie Curie in the discovery of radium and polonium, something like that. Okay, so see, specific ang radioactivity, but the radiation you cannot exactly say who among them who discovered this radiation, because there are multiple chemists and scientists played important contribution to that radiation, not only one person, something like that. You get the point? That's the difference between radiation and radioactivity. Okay? Okay? For you, think another difference also, because this is on the spot. This is what I learned in my 20 years ago in my profession in base chemical engineering. I don't know with you guys, if you can also share with me what is the difference between radiation and radioactivity. That's what I understand. Okay? Ganon. And then the radioactivity also, guys, it's more on nuclear transmutation of the elements, basing on the nucleus. Elements talaga siya, but radiation hindi siya focus comprehensive. Something like that. Okay? For example, from microwave, from sound wave, from light wave, like that, okay, from gamma ray, X-ray, visible ray, all covered by radiation. But radioactivity doesn't focus on the light. Okay, it's only on the element. Okay, how it will be undergoing the half-life after how many years, how it will be decayed after how many years. So you'll compute the half-life of that particular elements, and the isotopic characteristic of that elements, how it will be decayed after several years, something like that. Okay, that's gonna be radioactivity. Okay? Ganon. So ganito, who discovered radioactivity? It's gonna be Henry Becquerel. Because ano siya, guys? The one who will first discover is the one who will bring the credit. Okay. And then, if there's another scientist followed by them, their discovery will be highly specific na siya. Okay, so Marie Curie discovered radioactivity towards or by the application of polonium and ganun siya yung mga polonium and radium. But if we try to more in general, who discovered radioactivity? Your answer will be Henry Becquerel, not Marie Curie, because if Marie Curie, they are following only the original discovery of Henry Becquerel. Ito po, things like that, muna siya rule sa mga scientific discoveries. Get the point? That's why in Ohm's law, for example, voltage is equal to current and resistance. It's not Mr. Ohms who discovered current. Get the point? He is not the one who discovered current, but he is the one who discovered the relationship between voltage, current, and resistance. So it is more comprehensive rather than discovering along the current. And then the current is discovered by Tudor Maihan, something like that. Diba? Dili siya sikat because originally current like Yaha. So the contribution was focused to Ohms because he discovered the entire relationship between voltage, current, and resistance. But if you try to be strict, there is also the one who discovered the resistance, they also discovered the voltage, they're also the one who discovered the current. But in fact, the current is discovered by Mr. Tudor. Ganon. Okay, di ba? Parang, yung toki ko di ba? Ganon. Okay. Isa pa. Saan naman na siya, no? Ano sa weak nuclear forces? So, weak nuclear forces is the basis in the studying of nuclear chemistry. Okay, nuclear chemistry. For example, if you want to make a missiles to protect your country from the war. So how to do that? You need to understand clearly the nuclear chemistry, how to do it in your design. Because it involves a lot of protons, electrons, neutrons, like that of the nuclear chemistry. So you will consider also the infinite energy, time and velocity relationship. How these missiles can travel into the outer space or whatever, or to other country like that, as quick as it is. So you need to compute, okay? Like that. So you need to be mastering the nuclear chemistry and the nuclear transmutation. So if you have this mastery, then you can design missiles, a spaceship, and then you can also design a good reactor plant, nuclear reactor plant. Okay, this is really the basis. That's why there is also a specific course for this BS Nuclear Engineering, because this is specialized to this type of areas. Okay, because it needs a lot of study, guys, to know with nuclear forces. This is highly sensitive. If you are going to have a single mistake, then, oh my gosh, it will explode your discovery or your unit or your process or your facility. It needs focus for this in this type of course, BS Nuclear Engineering. Once it will erupted like that, tablatanan. Okay, so you should be careful. Usually, the one who will take this are extra genius and intelligent people. Really, okay, for this type of course, BS Nuclear Engineering. I think it's offered by the University of the Philippines, Diliman. I think so. There's no other places offering that one because this is this is complex. Okay, I think the most complex of all the study in pure sciences, it's nuclear chemistry. Nuclear chemistry under nuclear engineering. Not so much in petroleum engineering because those are only hydrocarbons. And we can purely manage hydrocarbons artificially by human factors. But this nuclear chemistry, anytime can happen if you cannot control the parameters. Okay, because at any time, these electrons, protons like that, oh my gosh, I cannot explain further. Okay, you get the point? That's why this is very, very difficult to study, the nuclear chemistry and nuclear engineering. You get the point? Mga kalangga ganon. Okay, so how can we play around this with nuclear forces? So, for example, we have different emissions or particles emitted. Okay, by an element, for example, we have let's say, alpha particle or alpha emission. This is radioactivity radiation, right? So, ganon. And we have the beta emission. Beta emission. Emission is just a particle ray, ha? Particle ray. Or mga ray to machuchu mo na siya, RAY. Those are an evidence that is really undergoing the process of radiation. Sa mga ray. Okay? Like that, so beta emission or beta ray. Ganon. Okay? And then we have also the positron emission. Okay? Positive positron emission. Okay. This is the negative, the positive electron is the positron emission. Okay? Then we have also the gamma ray. Okay? And we have the X-ray, which is the most popular. X-rays. So X-rays is very quick, having a very, very strong frequency. Yes. And then covers only a very, very short wavelength because it's too fast compared to the speed of sound and to the speed of light and for the colors as well. Okay, you get the point? Like that. So X-ray is very fast, huh? Too much high frequency, more than the speed of sound. You get the point? Speed of sound travels too fast in a solid rather than in liquid and a gas because it is compact, very compact in the molecules. You get the point? The compression wave will travel, very fast. Okay? You get the point? So if the question will say, is the sound wave travels more in liquid, true or false? Sound wave travels so fast in A, solid, B, liquid, C, gas, D, none of the above. Your answer will be solid. Okay? Because sound wave travels so fast in solid compared to liquid and a gas. Okay, then another one is different also, the light. Okay, the light travels too fast in a gas. Okay, so baliktad siya. Okay, that's why the speed of light is too much higher than the speed of sound. Okay, and the speed of sound can be experimentally done in situational basis, case-to-case basis, but the speed of light have a constant. The speed of light standard constant is 3 times 10 raised to the power 8 meter per second. The speed of light discovered by, Albert Einstein in the theory of relativity. Okay, E is equals to mc squared through time and space computation in scientific research, wherein this basis will be the binding energy, okay, of a certain object in the universe, something like that. Get the point? So mass and velocity relationship equation with regards to the energy, something like that. You got the point? Wala siya, guys. Okay, so mabalik ka sa uno. So alpha particle, beta particle emission, beta emission, positron emission, gamma ray, and X-ray. And we have also the, what we call this one? Like this, photon. Photon emission. This is the one I told you a while ago. Photon emission or photon rays, the particles emitted by the light. Okay, the fluorescent bulb, the incandescent bulb, the neon, or any types of lights around the world will produce a photon emission radiation. Okay? It's pretty clear, right? Okay. What else? Okay, wait for a while ha, kanina sa kong coffee, mag-activate akong brain cells. Okay? Yan pa sa iyo. Nakakaloka. Okay, manag-ingat sa ako din ilapit. Okay guys, wala nawa, tsaka ako lang sa ulo, makavlog lang po. Okay, muna siya. Okay, klaro na na. Now, I need to introduce a formula. Okay, like that. Okay, for this. Okay, like that. So, I will introduce the formula, for example, and then, I don't go to details because, this is only a preview. Okay, so preview meaning overview because as I said, if I will do it one by one, it will take me a longer time to do it. Okay, 10 years is not enough to do these things. Okay, because science is very broad. Okay, it will covers everything within and outside the planet Earth. Okay, nakakaloka, di ba? Okay, so we have. Okay, alpha, the symbol of alpha is just like this, right? Alpha emission, or ray, alpha ray. Okay, or ray. Okay, you meaning guys? Ano na siya? It was discovered mainly by the helium is our basis. So we have the 4 mass number of the helium and the atomic number of helium. Then we can say that also as 4 to alpha. Then if given an element, guys, just analyze that it's gonna be like that. You will add this one to the element that you're trying to undergo the radioactivity. For example, I will say that rubidium, ganon. Okay. Rubidium, for example, the atomic number is, for example, for the purpose of discussion only. Okay, 5, ganon. And then this number is 12. Then plus this alpha, then you can directly do the subtraction to make this atomic number equal, like that only. Okay, this is a very basic math, subtraction and addition only. Okay, you get the point. Okay, now we have the beta ray and the beta emission. So like this. So normally you will analyze. Oh my gosh. Okay, it will be covering the charges of that particle. So it will be put in the downside. For example, I have a beta. Okay, so beta in the radiation would mean electron. And then 1, 0, negative 1 electron, or 0, negative 1 beta emission. So in the question in the future, if we put small letter E and the beta will just be the same. Both are beta emission. Okay? But some books are putting B like that, but some books are putting electron, but just have the same meaning. That's why I told you to have different sources and reference books to understand further. Not only dependent in one book, because there are other books who are good at explanations. Okay, apart from your classroom instruction, if you are not satisfied with your instructors, okay, you have to outside from the backs, okay, and do it by yourself. Okay, maybe you can get more than your instructor. Something like that. You get the point. Okay? It doesn't mean that they are the instructors, so they are more good than you. Sorry po. Nakakaloka yung pagkasabi ko, di ba? Ay, nako, Junjun. Okay? Ang number 3, mga palangga kong hitad, di ko ano siya. Okay? Positron. Okay, ang positron mga palangga, kaliwa siya B or electromagnetic. Siyempre, negative siya. Naon mo siya ay, okay, positive siya, 0, positive 1 electron, or 0, positive 1 beta. Because this is the negative beta particle. No, positive, the reverse of the beta particle. Okay, if you have the beta particle, ang reverse niya muna siya. Muna ang positron. Charot. Okay. Now, ang gamma chuba chuchu, yung sa una mo ang gamma chuba chuchu. Okay? Ang gamma sa naman kanya siyang X-ray, ang naman siyang, okay, ganon, 0, 0 na yun. Okay? Okay, and then the photon will be like this, 0, 0. Okay? Muna siya yung photon emission. Okay, by the light. Ganon na, 0, 0 siya. Okay? And gamma X-ray is the most important one. Okay? Ganon siya. It's gonna be like gamma 0, 0, something like that. Okay? Ito pa yung mga palabang hitad. O, ganon, di ba? Any question? Any questions so far for this? The photon will be like this, the gamma will be like this, and the X-ray. Something like that. Okay? You get the point. Ano siya. Thank you so much for watching these videos about weak nuclear forces. Something like that. Then you can also double check because you know, maybe I'm wrong also with other discussions. I'm not really exactly 100% sure because you know I'm not studying now. Okay, I'm working and then I rely only on my stock knowledge and acquired knowledge and a little bit of research. And you don't know that if I miss something, then okay, I am wrong. Just correct me so that I can issue an error statement in my title description in my YT blog. Okay, something like that. Okay. Ganun lang siya. Okay, and then if you want to subscribe my YT channel, you can subscribe also if you want. Thank you so much. Bye-bye, God bless everybody. Ganon. Di ba mga palangga akong hit?